Python, the steps are the same. You can bring any variable into existence simply by assigning to it the first time. So that's what the author's talking about there. He says right here, a variable is initialized or created the first time a value is stored in it. After that, you can use it in expressions with other variables and values. When a variable is assigned a new value, the old value is forgotten. If I take that back and we look at that, and I have a equals 5, and I later set a equals 10, what happened to the 5? Oof, gone. Oof, I like that. Sound effect does it all. Oof, it's out of there. You're not going to find it. So it can hold something. It's like a box. But if you put something else in the box, you don't know where the other thing went. Shortcoming of the analogy. You can call it overriding, sure. So we have spam equals hello, spam equals hello, spam goodbye, hello is gone, right? And then there you go. There's the analogy.
Can you reassign the data type to the same variable?
Aha. So in some languages you can't, in Python you can, and that's all we're going to focus on, just so we don't get aside. Yes. Let's pay very close attention to that, and let's understand what the question was. It's Amy?
Yeah.
What Amy asked. So Amy asked this question. Amy says, we have, we have b equals 5, right? If I say b equals hello, is Python going to take that? What do we think?
Yes.
Yes. I should have asked that question before I told you the answer. That's the way things are supposed to be. It is going to take that, right? And the reason why it's going to take that is because Python, the variable's type, right, is part of that value. You can kind of think of it like that, right? So you can assign to a variable anything you want. What's up? In some languages, it is bad. I'm not going to get... Come out to pho if you want to know my opinion, which I will readily give. Yes, so Python has made a lot of decisions in the design of the language, and there are merits to both sides of them. The advantage here is that it's very simple. Python as a language is very simple, and this class is assuming no knowledge, which is why we're still on variables. But the point here is that you can assign anything to a variable, and it changes that variable. That's exactly right. And that's a very good question. And being that I just had a conversation with my friend that does C++ and databases, this is definitely something that, I know it will benefit a lot of people. Okay, so, has examples of illegal variable names. Okay, so when we have a variable, right, what could be a variable? You could have anything be a name of a variable, right? No, because if you did that, Python would have a really, really, really hard time making sense of stuff. Let me give you a case in point where that doesn't make sense so you know what we're talking about. If I say 5 plus 5 equals 10, equals, let's say, 2. There we go. 5 plus 5 equals 2, right? That doesn't make any sense at all, right? Why doesn't it make sense? Here's why it doesn't make sense. Because 5 plus 5 would be a horrible name for a variable. That would be a very bad name for a variable. I can say something like this. I can say, 2 equals 2. Right now I just created a variable called 2. But if I wanted to create something called 5 plus 5 equals 2, that would be stupid. It would be very complex, and it would be very hard to reason about that code. Right? So what does Python says? It says can't assign to an operator. Doesn't matter what it says. The point here is that you can't do it. There are specific rules for what can and can't be a variable. Right? And now we're going to go over those rules. And the reason why those rules are there is so your program can make sense to you and make sense to the thing that's reading it and working with it. It can only be one word. You can't have spaces in a variable name. That would be horrible. It can only use letters, numbers, and the underscore, right? And it can't begin with a number. Those are your 3 rules. You remember those 3 rules, you're going to be pretty good. So you remember those 3 rules, you can pick any variable name you want, right? You can have variable Mark, Zach. You can have variable Lumine. Doesn't matter. Anything can be a variable name. Lumine 5, Lumine 7, Zach 10. All of those are valid variable names. But if you get too crazy with it, you're going to run into these problems. And the end result is that I would say this. Different languages have different rules, but if you follow these 3 rules, you're generally speaking good for most languages.
What about keywords?
We're not going to get into that yet. We could get into that.
Just move on.
Yes. Maybe we will in a second.
No, I don't think he does.
Yeah, we're not going to get into that just yet. Okay, so we have valid variable names, right? Here's an example, balance, and we have an invalid variable name, current balance. And I would ask, why isn't this allowed? But we have the answer right here, thankfully, yes. The reason, you can't have a hyphen in a variable name. Current balance, right, is a valid variable name, but current space balance is not. 4 cannot be at the beginning. You can't just assign to a 42. You have to have a letter to start it off with, right? So 42 is not valid. You could do something like total sum, but you can't put a dollar sign in the middle of it. Because for Python, that's not a valid variable name. Here we have quotation marks, right? You can't have a variable start with a quotation mark, or have a quotation mark anywhere in a variable. There we go. We're done with that. Okay. There we go. Okay, so now we're getting into designing programs. I have.
It's ridiculously long, sorry.
Okay, no, I just wondered where it started and where it stopped before I tripped all over it. Okay, so we're starting now with this program. We're going to create a program, and we're going to introduce some new things that we can do, right? So far we figured we have these things called operators. We can provide 2 different arguments to them. Those arguments go on both sides of the operator. 5 plus 5. 5 is the first argument, the other 5 is the second argument. 5 plus 6. 5 is first argument, 6 is the second argument. Now we have these new things we're going to do. Print, right? So print is a function. So this works like you give it the function name, you start off with an open parentheses, and then you give it something. And we're going to get more into what that means later. But the point is, when you want to print something out, you can say print, and then open parentheses, whatever you want to print, close parentheses. So we're looking here at this function. This program. So we have, let's start off with the first one. This thing up here at the top, this is called a comment, right? A comment tells Python, ignore it entirely. So if Python's ignoring it entirely, who are comments for?
People.
Programmers.
And when I want to push this to code.
Humans.
I'm sorry, we had
Oh, for anybody who's seeing the code, like any human.
that's right, humans, right? Easy enough, humans. If you had no humans, you would need their comments. We'll get there someday. Thank you, Warren. But for us, right, sometimes you can reason about code just by reading it. Sometimes it's so simple that a comment doesn't add anything. It actually makes it more complex. But sometimes code is too complex to be reasoned about, or more complex than would otherwise be. So you want to just give people a little description about it, right? Think of it like the Cliff Notes. Maybe? So you can write whatever. So he says up here, this is a program that says hello and asks for my name. You just read that, now you know what the program does. What's easier, to read that and understand what the program does, or to actually have to read all this stuff to figure it out? Right? So, yeah, comments can be very useful. Now, he starts off when he says print hello world. That means he's telling Python, put this to the user. Give them this string, hello world, right? And then print, what is your name? So now Python has told you, hello world, what is your name? Now he's got this thing, my name equals input. My name is a what?
String. String.
No, who said variable? Variable, right? It is a string, it's typed as a string, but what I'm looking for is variable,
Ah.
right? And you know, it's a string because you're giving it a name, right? The point here is that input is going to go out to the user, it's going to ask for something. Input is going to return something, likely a string, and it's going to assign it to my name, right? Now, my name, if you want to run it, you want to correct that, you want to do it again, run the same piece of code again, right? You can run this twice. Python will ask you twice, what is your name, right? So you say, hello world, what is your name? And then you say, get input from the user and store it in my name. Then print, it is good to meet you, and then whatever the user gave you. The length of your name is, and now we have 2 functions, print, length, name. It's going to tell you how long your name is, right? And you say, print, what is your age? And we do the same thing, my age equals input. Then we're saying, print, you will be, and now we're concatenating it, right? Quick question from someone who hasn't answered, who hasn't called upon. What is concatenation doing, and how is this working? Anyone want to give that a shot?
Mashing strings together.
Bashing strings together, right? So we're taking this string here. I'm going to pull this up so people in the back can see it. We have this string here, you will be, and we're saying we want to concatenate, we want to mash them together with this string here. So whatever is happening here is going to turn into a string. And then we're concatenating it again with in a year. So let's go through this, right? Print you will be, and then we have your age, right? We're saying we want that as a number. Right? So if I give it 15, it's going to add 1 to 15 because we're taking that 15 as a string and we're saying we want to make it an int. So 15 plus 1 is 16. Make it a string. You will be 16 in a year. What is your age? Add 1 to your age. Throw it out to the user and tell them how old they'll be next year. Right? Okay.
How does it know that the my name is a string before the user inputs anything, and my age will be an integer before the user inputs anything?
Okay, so that's a very good question, and I think that's also what Robert was talking about. Input is always going to return a string, right? So it's something you should know, that the computer doesn't assume you're going to give it a number with input. So it's always returning a string, and you can make that string a number, right? So when you say int my age, you're telling Python, in this case, I need to interpret that as an integer. Okay? So with that in mind, Robert was totally correct to say that input is returning a string. But what I was looking for is that my name is a variable. Okay. So we're going to take this and we're going to run it. And I'm going to show you now why I don't like idle and why it totally works, right? If I take it here, we're going to pop it over here. Okay, we printed out hello world. We knew what that was going to do. I'm going to come over here and we're going to say, print, what is your name? Now I want you to see how this has a comment out here too? We saw the comment up here where we start and the whole line is a comment. And then we saw it down here. The number sign, right, starts the comment. It can be anywhere in the line. And then everything until the end is a comment. So anytime you see a number sign and it's not in a string, it starts a comment. And that keeps going until the end of the line. So now we're going to take this, paste it there, ask them, well, there you go. It didn't take me long. That's why I don't like idle. Because it is a pain for this type of thing. It's a pain to run code twice in it, and it's a pain to copy and paste code in it, right? It's just not. Now let me show you how you would do this if you wanted to use something like Python, which I hope everyone's got, or something similar to it. You can take it, I can paste it all right here. Now I can fix it up. I can say, okay, I want to make this, and I realize that this is going to be unbearably small, and I'm going to try to fix that here in a second. By the way, we had some PyCharm users. Does anyone know how to fix that off the top, or am I going to go just down here?
I don't.
Okay, what do we do?
You go to File,
File,
Settings,
Settings,
up,
hotter, golden, hotter. Okay, got it.
Editor.
Editor,
Actually, well, that was right there.
font.
Font. But the appearance might will make everything bigger, not just the.
So where's the appearance?
Down one. Here. Yeah.
Aha. Okay, use custom font. Maybe we should make it 22. That did absolutely. You tricked me. Let's take that down to something reasonable now. 16. Okay. And then apply. Okay. Sanity. And then editor. Okay. 18. No. What's in there? Okay, but I don't need this side panel and it goes away. Okay. So, in PyCharm, I can easily paste all the code, I can see all the code, what it looks like, I can change it, and I can run the whole thing. That's unique. That's what you can't get out of idle. So there's different ways of running code. Idle is really good if you want to run something really short. But when you start to want to edit code, idle is very bad. Because editing code means running that statement again, or resetting things up again. And that's just a pain. So when I want to change things up here, it's very simple. Now all I should have to do is I should go run, and I should just say scratch. And it should run it right here. What is your name? Evan. What is your age? 18. You'll be 19 in a year, right? That's how that works. Totally honest. You have a question? So the thing here is that this allows you to run that code very easily, and we can take it and we can look at it, right? And we can say, okay, well, what happens if I remove integer, right? What happens if we just assume something like that? What are we going to get? Anyone want to give it a shot? What's going to happen? Error. We're going to give it an error. What is your name? Evan. Now notice we don't have the error right now, right? This gets to Amy's question about, that's bad. Well, it's bad because Python doesn't know that you have an error just yet. What is your age? 15? No, I was going with 18, I'll stick with it. And then there's our error, right? So then that's the thing. Python at that point of the code, when it hits that point of the code, it says, hey, problem, types don't match, right? Only then can it throw that error. Okay. So we're gonna go back up here, and we understand that code. Does anyone have any questions about this? We kind of get this. This is our first program. We have to understand print. We have to understand variables. We have to understand the length stuff right here. It's a function. You give it a string. It tells you in integers, as an integer, how long that string is. Okay. And now what I'm doing is I'm looking. This is their example. They're running it. We already ran the code publicly. We talked about a comment. The comment is something for humans. Computers ignore it. We talked about input function, and it should say right up here, function evaluates to a string. There you go. Printing the user's name, went over that. Length. Length is very simple. You give it a string, it tells you the number. The length of that string. Okay, so far we've seen string and int. We've used them a lot. There's one more. Well, there's actually more than one, but again, we're not doing that. There's one more that the book is introducing right now called float. Float, you give it a number, and it makes it a special type of number. Does anyone know what the difference between a float and an integer is?
Yes.
Characters to the right of the decimal.
Characters to the right of the decimal, decimal.
It's a real number. A float's a real number, and you could take an integer and convert it into a real number, a float, which is, you could have 24, you can have 24.0, which would be a float.
That's exactly, that's right, yeah. Everyone is right. No one is wrong on this. Everyone is saying, everyone is right. We're all winners. So what was said was, it has a decimal, that's right. It has a fractional component to it, right? If I give you a number, right, to the computer, that number can store one thing. And as much space as you have for that number, you can only store a number in it. There's no different part of that number, right? A float has to have a different part, right? There's a part of it that's a number, and then there's a part of it that represents the fractional component, right? Computers can represent it differently. For the purposes of this class, it doesn't matter. So I like all of these answers because they all address different levels of that question, right? Without getting totally geeky. You see a decimal, it's a float. That's a perfectly valid answer. Okay, so we're running through this. We have string 0. 0 is a number. String makes it a string. Now we have the string back. String negative 3.14. What is negative 3.14?
A float.
Very good. Awesome. Negative 3.14 is a float. Integer? What is this? What is the 42?
Oh, this is string.
Bada boom. Okay, someone else. Let's go to the back row. Back row, middle. 6 people. Which one do you want to be a victim that I can call on?
Oh, prize.
No, not you. You're in the very back row. Purple, beigey, well-dressed guy. It's not the guy behind you. I know him really well, and you way outdressed him. I'm kidding. I love Marco. Is it okay if I call on you?
Yeah.
You're very attentive. That's why I'm saying, I just don't want to leave anyone out. Okay. So yes, we're gonna go down here. Negative 99. What is this?
It's an
It's,
Oh, it's a string.
aha, why is it a string? That's exactly right. It's that simple. You aced it. Don't stay quiet on me. Don't do that to me. Okay, behind him, we have 3 ladies and Marco. Would any of those 3 ladies like to give it a shot? Please? Please? Aha! And why is it a float?
Because it's a
That's exactly right. It has a decimal, right? So if I didn't have the 0.25 on it, what would it be?
integer.
And nailed it. That's it. You aced it too. You guys need to stop being so quiet back there. Okay, it's very simple, right? The 3 data types we're going over here. We want to take this float, we give it a string, right? And we're going to get back a float. And again, this is all, you only have to do this based on the operations you want to work with it. It's already in the computer. It just, the computer needs to know what it needs to be to do that operation, right? Okay. Okay, now, we went over this earlier and we said there were 3 data types. They were Marco. 3 data types we went over thus far.
String.
Integer.
Integer, one more. Float, okay, right? Now here's where the book is owning up to its own mistakes, right? Now here, I'm gonna ask on our genius in the back, Kenya, what is this? False. Is it a string, an integer, or float?
What, the false part?
Yeah, the false.
Boolean?
Aha!
Very good.
Aha, very good. See,
That was the answer we were looking
I
for.
tried to trick her, but no. It's not a string, it's not an integer, and it's not a float. False is a Boolean. It's a whole different type of data variable entirely. You can do different things with them. They're really cool. They don't introduce them yet as having different types of data, but we will. So stay tuned. That's a Boolean.
That is coming.
And I'll at least know one person that will ace it. Okay. So now we get on the summary. Now we're gonna get down here to the practice questions. We're gonna run through these, and then we're gonna hit the next section. We're gonna run through. Peter, should we run through these as a group or give time? What do you say?
I don't understand what you just said.
Should we run through these as a group publicly, or should we give time? 5 minutes, 10 minutes? What do you?
I have no idea what you just said.
The
There are some
questions.
questions.
Yeah, what about them?
Do you want to run through these publicly, or do you think we should give time for it?
I think we should
I
do
don't
them
understand
together.
what give time means. Is that some other, is that
Okay,
some
well,
code?
no. We'll do them together, right? Okay. So, what we're gonna do is we're gonna look at these, right? And we're just gonna try to go through these and say which one of these are operators and which ones are values. Right, here's what we can do. Let's start on the left. If anyone wants to pass, what you do is just point back and lead. And then I'll just skip you, right? Okay, the asterisk, is it an operator or value? You're kicking it off. You got 2 options.
Ooh.
Boom, 100%. This, operator value. Got it. Operator value. Got it. Operator value.
Operator.
Aha. Nice. Operator value.
Operator.
Going down, Peter. Operator value, right
Operator.
here. There you go. Numeric.
Value?
Got it. Okay. Which of the following is a variable and which is a string?
Before that,
Yes.
in the first question, isn't hello in quotation marks, isn't it an operator? No?
No.
No, it's a string.
What would you do with it? Let me ask you that. Hello in quotation
So,
marks.
to me it sounds like operator is something, some instruction you give and then it gives you a...
It's just.
Anyway, so maybe I'm just completely confused.
It's just
No, you're not. We're going to cover that, right? So if an operator is something you're gonna provide it an argument and it's gonna do something with it. That's a string. That sits in a part of memory in a computer and it never forgets it. It's like your age or your name, right? Your name, you don't do anything with it. It just is. You can rename yourself. You can call yourself whatever you want, but you can never do anything with your name by itself. It just is, right? Same thing with your age. It just is. So you can ride a bicycle, but you can't ride your name or ride your age. There's no verb there. The operator is something that's going to be done, like adding, subtracting, multiplying, dividing. Those are operations. 5, 6, hello, those are values. Okay, Does that make
So
sense?
then there are only 4 operators?
No, because remember, you have the plus on the string, concatenation, mesh two strings together. You have the plus for numbers. You have division, subtraction, multiplication, exponentation, 2 raised to the 5th power. You have a lot more. The equal sign, all of those are things that the computer's going to do, right? So, okay. Which of the following is a variable and which is a string? So, Mimene just answered.
The top one is a variable, bottom one's a string.
Great. Okay. Well, Lewis, you're acing it now. No, I'm kidding. Okay, name 3 data types. Lewis. You want to give me one of them? Give me one.
Can't think of it.
Okay, do you remember what this is here? The thing in the quotes?
I'd say a value operator. No, it's a value.
It's a value, but what type of value is it? Okay, no problem. Hey, we're all new here. What is it? Jessica. It's a string. There we go. So we have 2 more. Jared, what's the other one? Another type of data type. You following? There we go. Float. Zach?
Integer.
Integer. Got it. Okay, done. What is an expression made up of? What do all expressions do? That is a crazily vague question. We're just kidding. You want to do those questions? Would you rather be a tree or grass? You know, and why? The chapter introduced assignment statements like spam equals 10. What is the difference between an expression and a statement?
Ooh, that's.
Yes. We're going to skip that one too, because that's a very complex question that can be answered at different levels. You like that question?
Yeah, I would like to know
So,
precisely.
so I can answer that one in a way that's a little bit better than my analogy before. Expressions always can be simplified to a value, whereas statements sometimes it's just a command to tell it to do something and it doesn't actually happen. So 3 plus 2 can be simplified to 5, but if this is true, then do something else. That really, there's no simplification.
Okay.
You could do it in to cover expressions, evaluate, if you will, statements, execute. Maybe.
Yeah, but you just put it off then. So what's the difference between execution and evaluation?
Anyway.
Yeah, that's what I'm saying. That's going to get fun really, really fast.
How about this? An execution exercises some action, creates an action, whereas an expression can reduce to a value.
I think that the thing is, like, I would love to have that conversation. If I give a counterexample where that gets muddy, it's just going to blow everyone's mind. That's the position that I'm put into. So, yes, if these work for you, that's fine. The reality is that I think that you're just as well off with Ed's first statement and rocking with that, because we're on the first chapter. Ed's first statement was you can think of an expression like a phrase, and you can think of a statement like a sentence. And to be honest, that's where I will leave that off, because the rest is very technical and partly historical. And I just don't want to go there right now. So, why does the variable bacon contain after the following code runs? Bacon equals 20, bacon plus 1. What does bacon equals this? Wait. Okay, where did we leave off? My friend.
21.
It equals what?
21.
Okay, let's go one over. Do you think it equals 21?
No, it's not an assignment. It just is bacon plus 1.
And
Print 21.
2N
No,
Susan has got it. Okay, so what 2N Susan just said was that bacon equals, by the way, 2N Susan is on Discord. If you're not in the Discord, join it, because 2N Susan is, and it's awesome. Bacon equals 20. Bacon plus 1. Did I get that right?
Yeah, but one and Susan is way more active than I am. She's got a lot of information.
You're going to become more active because you're going to have 30 friends. Bacon equals 20. Bacon plus 1 doesn't change the value of bacon, right? And 2N Susan nailed it. She said there's no assignment, you know? You can do something, but the only way you can change a value is with an equal sign, and there simply isn't an equal sign there. So if you wanted to say bacon equals 20, bacon plus 1, here's what you would do, right? We're going to come down here. Let's use something that's more culturally sensitive. We'll use Coke equals 1, right? Coke equals Coke plus 1, right? There we go. now we have Coke and it equals 2. If I say Coke plus 1, now we get 3, but did we change the value of Coke? No. We didn't. Coke stayed the same, right? So there's the reality. The reality is that you only change a value with an equal sign. Very simple. Okay. Do you have a question?
I think it's the same thing. I put Coke plus 1.
Okay, very cool. Don't confuse what you get back as an expression, right? What you get back when you evaluate something as being what the variable is set to. They're two totally different things.
Is what you're saying the third line of code that you wrote basically is nonsensical? It won't take that as anything new because there's no equal sign?
It won't store. There's no storage. You're doing.
The easy way is you can stop thinking of this as an equal sign. This is an assignment operator. I know it's typed as an equal sign. I know we've called it an equal sign forever, but there's no equality. This is store the right-hand side into the left-hand side. And so this is not Coke equals Coke plus 1. This is Coke is assigned to the value of Coke plus 1.
That's it. Yeah. So, okay, very cool. Let's go down here. Why is eggs a valid variable name while 100 is invalid? Who wants to hit on that? Why is 100 invalid? Wait, Susan's done. Let's do it. Why is 100 an invalid variable name?
Because you can't start with a number on a
That's it.
variable.
Bada boom. Marcel, my friend. Question number 9. What 3 functions can be used to get the integer, floating point number, or string version of that value? What are the 3 functions we got?
The three functions for you get an integer, floating point number, string version. It's that STR with the parentheses.
Bada boom. One of them's down. You got 2 more to go. Read what we're trying to go to, and then think of a mnemonic, right? Floating point. Okay. Bada boom, you got it. Okay. So now it floats down in. There you go. That's simple. Okay, Dan. Why does this expression cause an error? How do you fix it? I have eaten 99 burritos. What's wrong there?
99 is an integer, and the other 2 are strings.
That's exactly right. How do we fix it?
Change 99 to a string.
That's exactly right. How do you do it?
You could do str, close paren, open paren, or with 99 in the middle, or you could put quote marks around it.
That's exactly right. Very cool. Okay. Okay. Look, here's the extra credit assignment. Search the Python documentation for the length function. It will be found on a web page titled Built-in Functions. I'm not going to do that because that's stupid. Teaching people how to use Google is not fun. So don't use Google on your own. What I am going to show you though is that we have this thing. We go back to this REPL, right? We go back to our idle. We go back to our Python. Python has all of the abilities to look up this stuff up, right from Python. You don't have to go out to Google, and it's actually more useful to me. Experienced programmers use the documentation language comes with, because it's always more efficient, unless you're reading the official documentation on the web. So we want to find out here what is the documentation on the len function, right? That's what it said. It said it right here. Documentation for len. How do we do that? Open up Python, right? Help len, just like that. Enter. Up, length takes an object and it returns the number of items in a container. There's your documentation on it. It's that simple, right? So from within Python, you can type in help and you can give it any function name and get an answer back. Now I'm going to blow your mind with 2 more things. If you type nothing and you just give it help, and you give it open and close parentheses, you hit enter, it even comes up and it tells you, hello, let me help you out. Right? It's very simple. Here's something really cool that it tells you here too. It tells you the address of the tutorial. It's another resource you can use when learning Python. There is an official tutorial for Python. It helps you get into it. It has nothing to do with automate the boring stuff. If you want additional help, thorough help, that's another great method of learning Python. Okay, and it tells you right here, there are different things you can get help with right away. Modules, keywords, symbols, or topics. We're not going over any of them right now, but all you have to do is type in keywords, and you can see what those keywords are. I lied. We're going to go over keywords right now. And then we're not going to go over any of them right now, because Peter asked a question about keywords, and I wanted to hit on that. So we talked about a variable name, and I said, what is a valid variable name and what is not? Do we want to do names? Is everyone here cool? Probably. Are you cool with giving me your name? Anyone in this class not cool with giving names? Because we're going right to the next target. Okay.
Oh, me?
Yeah, yeah.
Me. Oh, okay. Yeah, I don't care.
What is your name?
Christina.
Christina. Awesome. Christina, we were just talking about variable names, and we said variables can't start with
A number.
a number, right? Well, here's something else they can't start with. If you look right here, you're going to see special words. None of these have a number, and none of them can be variable names. Why? Because these are words that mean something special to Python, and we're going to go over a lot of them later. You can't call a variable false, none, true, and as. Why? Because all of that means something somewhere else, and it would blow Python's little brain if you did that. So those words are reserved, and we call reserved words keywords. That was asked in the question. I just wanted to show it off. On top of those three rules we have, here are the exceptions, the irregular names. Okay. Next to Christina, we have
Andres.
one more time.
Andres.
Andres.
Like Andres. Andrew with an S.
Good.
A-N-D-R-E-S.
Andres.
Yeah.
Andres. Okay, very cool. I am actually stupid. Your name is awesome. So we're out of questions. I don't have anything for you. So you automatically you get lucky. No, I'm calling you later. You don't get lucky. Cool names don't get you that. Okay. So flow control. Moving on to the next chapter. Okay. So the book shows these little diagrams. What we're talking about here is we have.
One quick question,
Yes.
just because I just figured this out. If you go into keywords and you start typing in keywords, like type in help and go into keywords and everything, how do you get out?
Okay. So we're gonna go over that, right? That's a good question. We typed in keywords. Now, how do we get out of the screen now that we're in it, right? Does anyone know the answer?
Q.
Well, it says right
It says right where in the same paragraph.
Just type.
Just type, but in the second paragraph.
Aha, just type, right, there you go. So it actually tells you right there. Yes, okay, so there's three answers to this. One of them is Q, or quit, and then the other one is Control V or Control C. It will get you out. So Control V, you're out. Okay, so, but Q is easy, so just use Q. Okay,
Can I ask one question?
yes,
Is
Amy?
Python case sensitive?
Say one more time.
Is Python case sensitive?
Is Python case sensitive? Yes. Yes, it is. Okay. So we have programs. We've learned about variables. We've learned about some of the things we can do with them with these operators and these assignment things. Now we're going to talk about how we use them. And one of the things that always comes out, and by the way, when you're a programmer, you will hear this all the time, is pseudocode and flowcharts. That's how the whole rest of the world that doesn't understand us communicates with us. What does it sound like? It sounds like, well, if I want this to happen, then do that. That's where business starts at their communication levels. If I want this to happen, then do that, right? And then it just gets closer to where we're at. So here's an example of a flow chart. What we're doing here, we start off with start, is it raining? If it is raining, we go over here to yes. If it's not, we go to no. If we have an umbrella, we go to yes, and it tells us to go outside. So if it's raining and we have an umbrella, we can go outside. If it's raining and it's not, we can just go outside. Let's go down here. Is it raining? Yes. Do we have an umbrella? No. Right? Wait a while, because we don't want to go outside without an umbrella. Or what happens is we can say, do we have an umbrella? No. We can wait a while. Is it raining? Okay, that's the next question we get asked. If it's still raining, wait more. That's what they're doing. They're looping back. If it's not raining, then go outside. Right? So, is it raining? Yes. I have an umbrella? No, I don't have an umbrella. So wait. Okay. Is it still raining? No. Go outside. And so that's how we go outside. And we're factoring in rain and umbrella and how much time we wait and all that other kind of stuff. It's not that complex yet. Okay? It's telling me that my ad block is being overly aggressive. Let me turn it off on this side. Yeah, I thought Control R would do it, but maybe not there. Okay. So this thing in the middle of this author's site, for those that don't know, this is actually a place where you can type in code. Should be able to type in code. Okay, this one you can't type in code. That's confusing. Okay, let's ignore that thing for now. Oh, no, you can type in code. It's just really, really slow. There you go. Okay. So yes, you can type in code there and he's showing that to you. So here's where he's introducing Boolean values. So he says, while the integer, floating point, and string data types have an unlimited number of possible uses, the Boolean data type only has 2 values, true and false. Right? So all Boolean things have to be reduced to true or false. Now you actually see it, Boolean data type. So the author told you 3 types in chapter 1. Now we got our 4th, Booleans. Right? So he's showing you right up here, and ignore the stuff that I typed in that broke things. He's saying spam equals true, spam, and it's returning true. True, capital T. Python is case sensitive, as Amy pointed out. Capital T, R-U-E, is how you type in true in Python. Capital F, A-L-S-E, is how you type in false. So those are 2 special values, and you can do cool things with them. So, and we're going to go over some of those later. So we have now, Ed pointed out earlier, right? He said equals is not really equality. It's not testing for equality. It's assigning, right? Python made the decision now, not always that way, but now it is. A equals 5, right? Sets A equals to 5, right? There's another operator now that tests for equality. So you can say A equals 5, right? Now this doesn't assign to A. This says, is A equal to 5? And it's going to return true. It can only ever return true or false. Is A not equal to 5 is false? Is A equal to 5 true? So we come down here and we look at these. We have equal to, not equal to, less than, greater than, less than or equal to, and greater than or equal to. And these are all part of this comparison operator. So we've seen assignment operators, we've seen math operators, and now we've seen comparison operators. And here's some examples. 42 equals 42, that's true. 42 equals 99, that's false. 2 not equal to 3, true. 2 not equal to 2, false. Very simple. We go down here, we're looking at these are string equality. Dog is not equal to cat, true. True equals true, that's true too. Why is it true? Here's a question for you. Let's go back. Andres. Andres, did I get it right?
Yes.
Oh man, got myself. Okay. I thought I missed that one. Okay. True is a Boolean what?
Operator. Expression.
Data type, right? It's a data type. If it was an operator, it would be doing something. But true by itself doesn't do anything. It just is, like your name, like my name. So if it just is, it's a data type. So we say here that true equals true. We're comparing true to true, right? Robert.
True is a value.
Yes.
Yes, true is a value.
Boolean value.
That's exactly right. That's my oversight. Very good. True is a value, right? Boolean is the data type. But my point here is, and that's absolutely correct. That's my own fumble. That when we say true equals true, we're testing whether or not true is equal to true. That equality test is there. We can do that equality test because true, just like 5, is a value. It's of a different type. 5 is a value of the integer type. True is a value of the Boolean type. Just like we can test to see whether or not 5 is equal to 5, we can test whether or not true is equal to true. These 2 things can be compared. Not to themselves, but they can be compared to other data types, right?
But 5 could be true. That's
5 in Python is not true, right? Python only true is true.
if 5. Okay, all right.
So we have here 5, right? And we can say 5 equals true. We cannot, because these are 2 different types. Actually, you can.
Okay.
I thought that was going to actually error. So Python will return false if they're not of the same type. That's what's actually happening. The thing here is that like any value, you can compare them to themselves. Ed.
What you're actually receiving back is not the value of 5 or the value of true, but when you do a comparison resolves to a third value, Boolean value of whether that statement, that little snippet of text, is factual or non-factual. And so 5 will never equal true. So that statement will always be false.
Yep. you can compare any values together, right? Even if they're of different data types in Python. So here we're comparing an integer and a Boolean. It's always going to be false. Python just tells you false.
But you
Okay.
can't compare true to true in lowercase, you'll give an error.
No, it won't give you an error, it'll just say false.
It'll just say. Well, that's because lowercase true is actually not special. That's a syntax error. So if I say true equals true like that, then what you actually get is true is not defined. And that's because only the uppercase true is a Boolean value. The lowercase true, it's nothing special. Right? Uppercase true is special. It means that this is a Boolean value. But lowercase true is no different than something like this, ASDF. ASDF equals true. Right? This is the same thing. Both of these are syntax errors. They're both the same types of syntax errors. Am I throwing you off? Or you
No, it can be, because it's not a special word, the lowercase true, somebody has probably used it for a variable assignment name.
Okay,
And we
that's
need
another
to
really,
terrible.
okay, so let's talk about that, right, because that's fun too. Malicious trolling. If it's not special, what does that mean? What does it mean if it's not special? It means that you can actually say true equals 6, right? And now I can say true plus 1. Don't ever do this. But what I'm trying to show you is that uppercase true and lowercase true are totally different. One of them is special, and one of them is just like anything else. And just like anything else, you can assign to it, make it a variable, do all those horrible things. And yes,
say
very
true,
bad
true,
idea.
And
true,
the
get a
reason
false.
it's truly horrible is because, Evan, now you can do that same comparison with lowercase true, as compared to 6.
Yeah, we can keep going on about horrible things. That's not what we're talking about.
Well, I was like,
But-
don't
but
do that.
horrible things are one of our favorite conversations. It's fun.
But if you're working with one of these condition things, that this is what this is all about, right? And you want to say that something is equal to 5, and then you want to say if that something is true, then isn't the thing, its existence means that it's true?
In Python, okay, this gets down to like, what do you know and what do you do, right? You obviously can do this in Python. You can say something like if 5 equals true, right? You can do, well, no, you can't. You can do 5 equals true. It would look slightly different for a conditional.
Well, no, just take a variable,
Right.
assign a value to it, and if it's got a value, then it's true in an if statement, or
Yes, but you could also do something like, the thing about these questions is they're going to require me to go a lot more in depth.
well, that's what he's going to do for the next 10 pages.
You could, right, but that's the next 10 pages. You could do, like this. You could do not equals to nil, right? Or none, rather. Not equals to none is the Python one. And then that will tell you whether or not that variable is set and has a value. That to me looks better than the opposite. But I don't want to go into that now, so let's leave that alone. And we'll get there, I promise.
So any number except for 1 is just false. Would evaluate if you were doing any comparisons of the Boolean. Like
Python is actually going to check the types. So 1 itself is not a Boolean, and trying to do something like the old C trick of if 1, that is not going to do what you think it is.
Right.
Okay, but 1 equals true is true.
That's right, because now you're doing a comparison operator, and so you'll see whether or not 1 is equal to 1, and the evaluation of that comparison will return back to you.
We're gonna, start, I never stopped it, so I did stop it just now because that's really important. Okay, let's give that a shot. So we're gonna get back now.
Content is provided under a Creative Commons.
That was the author. Okay, let's get back to the thing. Okay, so we're gonna skip over this because I don't want to get too far off this. We have Boolean operators. So we talked about arithmetic operators, right? We can say 5 plus 5. We can do some really good things with Booleans too. We're going to take a look at some of them now, and this helps us reason about programs and create that flow chart, right? So when we have something like true, right, what can we do with it that makes sense? In my opinion, true equals 5 doesn't make sense, even if Python accepts it. That's why I don't have that in my code. But you can do things that make sense with true, like true and true. That makes sense to me, rather true and true. So you can say true and true, and Python returns true. This is part of the Boolean logic rules, right?
Right.
So Python gives you some operators that make sense. You can say true or true, and you're going to get back true.
Mm-hmm.
You could say false
Or false.
or true.
False.
True. That's true.
False
Oh, or, right,
true,
there's or, right.
right? You could say false or false.
That's
You get back false. Now, why is this useful? It's useful for things like this. I can say
Conditional
say,
logic.
my age equals, let's say, 18, right? And I can say Ed's age, right, who is teaching the next class, and we can say 127.
2 to the 8 minus 1.
There we go, yeah. 2 to the 8 minus 1. So now what we can do, right, is we can look at these two things and we can start to do work with them, right? So I can say here, my age is greater than Ed's age, right? That's going to return true, which is really cool. My age is, no, I was thinking in my head the opposite. Ed's age is greater than my age.
There you go.
Is going to return true, right? It's telling you Ed is older. That's what that would be. Is Ed older? Yes, he's older. Now you can say or, right? Or we can do, well, Ed is already older. And, right? Ed's age, is Ed older, and is he less than 200? Right? If I hit enter now, you're going to see it say true, because Ed's less than 200. We've defined Ed as being 127. But if I want to do is Ed older and less than 100, it's false. So these types of things allow you to chain together different statements, right? And simplify them. Like we said earlier, take expressions, reduce them to a value, take expressions, reduce them to a value, so on and so forth. That's how you're going to start creating programs that are more complex, right? So now we're testing for two things. We reduce both of them to Booleans, and then we say, is this, which is true, and this, which is false, is it true or false? And that ends up becoming something like this, true and false. True and false is false, right? So, if you don't, does anyone know the Boolean truth table? Does that make sense? Have people heard of it or seen it?
Yes.
If you haven't, true and true is always true. True and false is always false. You have to have true on both sides of and for it to be true. And on or, you have to have true on either side, right? So if I say true or false, it's true. If I say false and false, false, right? If you have two truths, it's still true. So this is how we speak English. This is just how a computer reduces it, right? If I tell you right now, go to the store and pick up a carton of milk or a carton of apple juice, right? You have to get one or the other, right? If I tell you to go to the store and pick me up a carton of milk and a carton of apple juice, you have to get both. What we're doing is these English terms for this just get put right into the computer program. And they help you write those programs or your modeling and stuff. Okay. So not is an operator, and essentially just inverses it. If I say not true, it's false. If I say not false, it's true. That's all there is to that one. Very simple. Okay. So now this is where the author introduces mixing Boolean and comparison operators. 4 is less than 5, that's true. And 5 is less than 6, that's also true. So the result here is true. 4 is less than 5 and 9 is less than 6, that's true. And false, which makes it false. By the way, in case you don't get this notation here, this is probably also worth pointing out. The author is typing in both of these, right, at the same time, and Python is giving you back two answers in the same order. Right? That's just the way this web interface works. It's not the best, but that's how this web interface he's doing it works. So here's something more complex. Now we're seeing how we can build it up. 2 plus 2, we reduce that, what do we get? 2 plus 2? 4. Easy. Is 4 equal to 4?
Yes.
True.
True.
Right, so we have true on one side, and not, right, is 2, what's 2 plus 2?
4.
Is 4 equal to 5?
No.
So that's what?
Not no is true.
Not false.
It's false. So we know that this is false, right? I said that. So we know we have here true and not, false, and what is over here? 2 and 2 equals 2 plus 2. Is that false?
True.
It's true.
Is 2 plus 2 equal to 2 times 2?
Yes, that's true.
Okay, true, right? The only one where you get that. Usually, I like that. Yeah. So we have this right here, true and not, true and false, right? And we hit enter on that, and we get true, which is exactly what the top says, because it gets reduced to that. So we look at it and we go, okay, so what's happening here? Well, what happens is, you go up, the author says, it doesn't actually talk about the fact, yeah, here. What's happening here is that this is getting reduced further, right? So true and not false and true.
Yep.
What is not false equal to?
True.
True. So we're going to take it and we're just going to replace this. True and true and true.
It's true.
So if we say true and true, what does that get reduced to?
True.
True. And my thing just restarted. That's really annoying. So we had true. What is going on here? There we go. Okay, I think that's going to solve the problem. There we go. Let's give it one more second here. Okay, so we had true and true, right? And I was saying, what does it reduce to? It reduces to true and true, which is just simply true. And that's how that links. Those are the last steps. So you can take any Boolean operator and Booleans on both sides and immediately reduce them. And that's all he's doing there. Okay, we have another one. Is this the same one? No, this is the one that we did. Okay. And he's actually showing you how he's doing it. So left and right, both gets reduced. First one, left, and the second one, right, and then true and true is true. So now we're going to get into flow control. And what we have here is different things we can do. So we talked about it earlier, and I said that when you talk to business people, they're going to say, if what I want, then do what I want it to do. Something like that. Like that's how people think computer programmers talk. Well, that's because if is something everyone knows. And if is very simple. If works like this. You take right down here the variable and the literal you're comparing it against, and if it equals, if the name equals Mary, then this code block underneath is going to happen. Right? So the next question is, what is a code block to print? We have 2 indents. See that? See how I'm doing that too? So that's telling you that if this is true at the top, all of this stuff underneath it runs. So is the name equal to Mary? Mary's up here. We're testing to see whether or not Mary is the same. It is. So this becomes true, right? And then all of this code underneath it works. Hello, Mary. If password equals swordfish, and it does, we already know that's true. And we're just going to print it out if true, and you get access granted. Right? And that's exactly what happened when they ran this code. Hello, Mary, access granted. Because both of these evaluate the true. So now we're getting into how we design an if statement, right? We already talked about indentation as prime. The other thing that you need to know when you're doing an if statement is the colon. And that's really all there is to it in Python. So you have colon and you have tabs. Now this gets back to one of the other things we talked about, idle. I said why I don't like idle, because it's a pain to edit things. With Python, it's tab sensitive. If you write this line in idle, and then you write this line in idle and you forget the tab, you have to go rewrite the whole thing. That becomes really, really tiring. So if you take this over here, and we copy the same code, right? We can say if true, this runs. And then I run it, and it prints out right down here, this runs. Now if I screw this up, like I frequently do, and you forget the tab, and you run it, what are you going to get? Expected and indented code block. But because I'm using an IDE, the advantage, I can just go right here, tab, and then do it again. And that's it. You don't have to rewrite all that code like you do in something like idle. Okay.
I have another question for you.
Yes?
How many characters does the tab have to be? Because sometimes I set my tab spacing like 4 characters. Does it have to be 5 spaces or 4, or does it just have to show sense that there's a tab there?
I don't, okay, here's the deal. I use tabs. So to be honest with you, I don't actually know the answer for spaces. I want to say it doesn't matter.
No, I'm not saying spaces. You know, in some IDs, you can set tab equal to 4 spaces or however many spaces you want.
But is it putting in spaces when you hit tab, or is it just changing the display?
So you're saying as long as it recognizes a tab inside the character, it doesn't matter what displays because.
That's right. Tab is a tab is a tab, and you can change how it displays in your IDE.
Okay.
Right? Some people use spaces, and I don't think it matters either. I think that Python will just look at the level, right? So if we come down here and we say spaces instead, like I'm using a tab, but let's just do spaces. Here's 2 spaces. Does it work? I assume it's going to work. It works. If I use 1 space, is it going to work?
Okay, just so it sees some type of
So it's at least
indentation.
1 space.
It has to be at least 1 space, and it has to be the same throughout. That's right. That's your rule. Ed?
So this, when you say that some IDEs use 4 spaces for tabs, there are also IDEs that when you type tab, it actually inserts 4 spaces. And this makes it even more confusing. As long as whatever is indented in the line above, it is indented in the line below, Python sees those as the same level of indentation. But if it's different in any way, all bets are off.
Except I don't think you can mix spaces and tabs. No, that generally doesn't like that.
Guys, let's have that conversation
a
with
little
fun.
bit.
Yeah.
Let's leave something for fun.
How Python handles mixed spaces and tabs is a fun conversation, I'm sure, but not here. But yes, it's all valid. You know, it's gonna work. Okay, so we have here name equals Bob, and then we say if name equals Alice, print hi Alice. Is Bob equal to Alice? Okay, now we did underscore Robert. Is Bob equal to Alice? So what gets replaced here, where name equals Alice?
I think you meant to ask is the name equal Alice.
Yes, there is name equal to Alice.
So then we'll say hello stranger.
It will be, but what does this effectively reduce to?
False.
That's exactly right. Name isn't equal to Alice, so it gets replaced with false. And because it's not equal to Alice, this block of code does not run. And this block of code underneath it, else, does run. So here's the takeaway. The takeaway is this. When you run an if statement, you can always create a statement that runs as an alternative. And that alternative is just else, right? So this is the first block in the if statement. That happens if this is true, the top. Name is equal to Alice. This is going to run. If it's not true, else, this runs. It's that simple. It's just like English. And then we have a lot of flowcharts here. If you like flowcharts, by all means, do it. Okay. We have another thing here. Sometimes you want to check if you have 1, 2, 3, 4 things. You know, you have different conditions you want to test for, right? I'll give you a case in point. If I say you go to HEB and you get a free bag of potato chips if you get a rotisserie chicken or a turkey breast, right? Then when you check out at the end of that line, it's going to say, do you have a rotisserie chicken in your cart? Do you have a turkey breast in your cart, right? So if you have the first one, you can give 1 discount. Or if you have the second one, you can give another discount. You can structure things like this. Let me clean that up a little bit, because that didn't make all that much sense, right? If I say this, right, let's clean that up. If I say this, if you have, it's really hard to get these examples off the top. So if you say something like, if you buy what do you?
If you're over 65, or you bought a chicken.
Yeah, but we're trying to explain else if.
Oh, else if?
Yeah.
Well, I mean, it's just any kind of policy where it's a lot easier to express it.
Here's one. Here. Let me give another one. Okay. Here. If your age is over 65 and you purchased the chicken, right? Right. Then we can do one thing. We can say here, you could say something like sales total, and then you could say equals sales total minus 5. Right? We're saving $5 because you're over 65 and you bought a chicken. But if you purchase the chicken and you're not over 65, right? Then what's going to happen is your sales total is going to equal sales total minus $2, right? And here's the deal. The deal is, yes, in Python it's elif, E-L-I-F, else if, right? Now what you're doing is you're saying if you're over 65 and you purchase a chicken, you're going to save $5. But if you're not over 65 and you purchase a chicken, you're going to save $2. Chickens are discounted $2. If you're over 65, they're discounted $3 more. So there you go. But what you don't want is everyone that comes in that purchases a chicken to get the $5 rebate and the $2 rebate.
Right.
You see it? You don't want that because now all of your chickens are going to be $7 off, right? If you're over 65. So this is what you do. Use elif. And that tells you only one of those blocks can run. So here we have the first block. It only runs if the top is true. Right? If you're over 65 and you purchase a chicken, you run this code. Else if you purchase a chicken, you run this code. You don't run both of them. Now if I removed it, and I got rid of this elif, and I just said if, let's take a look at that. Now I have 2 blocks of code. What happens? What happens if you're over 65? You get the -5, and then what? And then you get the -2. So this is the difference. The difference here is that if you have the elif, right, the else if in Python, you can get one or the other. If you remove the L and you just have the if, you can get both. Because now you're testing both things for true. If they're true, you can execute both code blocks. Does that make sense to everyone? Because I turned that really horrible example that I muddied up the first time, my bad, into this one. I think this one's actually pretty good.
Not bad.
Not bad? All right, so that's your takeaway. elif, you're only executing at most one code block, right? 2 if statements, you can execute both code blocks. And if you have an else anywhere, like even if you had this, else if, else, and then you could say something like here, else,
Sales total equals sales total.
sales total equals here. Okay, so someone tell me what that code does, because this doesn't make any sense. I just want someone to read it so they can kind of reason about it. Zach, you're already laughing. We have what's the name in the back? That's absolutely. One more time. I know your name online. Danielle. Danielle, could you tell me what this does? Did you want to give it a crack?
Alright. So the whole if,
Yeah.
Okay.
What does that last piece do? The else.
the else, if neither prior condition are met, it adds 5 to the sales total.
Right. So the first condition is met if you're what?
Over
If you're
65.
Both over 65 and you purchase chicken.
Right. And the second condition is met if when?
If you are not over 65 and you purchase chicken.
That's beautiful. You said that exactly right. Props. And the third condition is met when?
If you are not over 65 and you did not purchase chicken.
Or that's not right. I'm sorry. That's just look at it one more time.
Excuse me, you're correct.
Uh-huh.
If you did not purchase chicken only, yes.
That's right. So the third clause gets hit if you did not purchase chicken, right? If you didn't purchase chicken, your sales total goes up by $5. If you did, it goes down by $2. And if you're over 65 and you did, it goes down by $5. Does that make, I mean, none of that makes sense in the real world.
What kind of grocery store?
And it illustrates what's happening here with the if and else if. So you, people having, this is, if I make this reasonable, everything else gets crazy.
What kind of grocery store are you running over there?
Yeah, it's the Dr. Seuss grocery store. You don't buy a chicken, your bill's $5 high. Come into my store and don't buy a chicken, you're walking out with a $5 bill.
It makes sense if everything else was beef. You just cost more chicken.
I wish I could, I'm
You
gonna.
didn't have to walk out with beef, you could just walk out with a $5 bill.
Yeah.
Or not going there in the first place.
Okay, not just did I not make it bigger, but I totally lost where I was at. So, what we're gonna do is we're gonna go through it and we're done with the if statements, right? So, we're moving on, an annoying while loop.
I have a question.
Yes.
Is that else applying for elif or for both of
Yes.
them?
Okay, so
Only the one above it.
No, it applies for both of them, right? So let me explain that here. If we do this, if I say here, if false, no, if 4 is less than 2, right? And then I say else if, right? And by the way, this is the way this is pronounced. You don't really pronounce this elif, right? That'd be really obnoxious. It's actually pronounced
It's a
else.
name actually. It's a Turkish name.
Oh, okay.
Female name.
Interesting. So
Wait, what
we
did she
have-
say?
It's a Turkish name.
Oh, okay.
A female name. Yeah.
So we have if 4 is less than 2, right? And then I'm going to give it another one. If, let's say, 100 is less than, why not, 2? That's also false, right? Then what I could do is say, weird. That's a good thing to print out if
Print,
it happens,
or print never happens because it's always false.
right? Okay, and then I could say here else, and I could say print.
It's,
There we go.
it's always else.
Right? It's always else. So the else applies to both the top and the bottom. Now here's the thing. If I say 100 is less than 200, now the else never runs. Never. Because you've satisfied the condition above it. If I remove that and I say is 4 less than 200, the else never runs because you've satisfied the first condition. The else in a combined if statement only runs if none of the conditions are satisfied. Right? If the first, then if the second, then if neither of them, else. You can think of it like that. Okay. Flowcharts, skipping. Okay, so we have this thing here, we're introducing a new thing now called while, right, which is a looping construct, and we're gonna probably just barely nick this before we get to the problems. So we're probably not gonna finish the problems in this class, for this one either. But we say here, name equals an empty string, while name is not equal to your name, right? Please print your name. Name equals input, print thank you. Someone help me reason out what this does. Where did we leave off? Robert, Liz. Liz, help me reason out what this does. Explain this.
Oh, I can't.
Okay, you want to skip it? Next to Danielle.
Oh, bro.
Pearl?
Yeah.
You want to help me reason out what this does? Give me a run through.
I wasn't really paying attention, but I can try and.
You want to give it a shot? Or?
Sure.
Yeah.
What were your questions?
Explain to me what this code is doing. I can make it.
Oh.
What?
There we go. I'll make it bigger.
Okay, you have a variable that's name,
Right?
and then while name
So.
is not your name,
Right.
then you should. Well, it would print. Please type your name. And you can type your own name. Someone has to do it.
Right. So.
When they do it, print thank you.
Okay, that's pretty close. Let's clean it up a little bit. I'm gonna help out. So while tells you as long as this condition evaluates the false, right? I mean, let me change that. As long as that condition evaluates the true, you're gonna keep running that, right? So while evaluates and continues to evaluate, so long as that condition is true, right? So what's gonna happen here is name is equal to an empty string, and then we say while name is not equal to your name, it says please type your name. And then it says name equals input, and then it says thank you. This is a jerk program. It asks you what your name is, and if you say it's Pearl, you say Pearl, when it asks you, it's going to assign your name to Pearl. So name is going to be Pearl. Then it's going to say, okay, going to come up here, and it's going to say while name is not equal to your name. Is Pearl not equal to your name? Yeah. It's not, right?
So it asks your name
Pearl
again.
and your name are different. This is a string, your name. They're different. So because they're different, right, they're not equal, this statement is going to evaluate to true. And because it's evaluating to true, it's going to come down here and it's going to say, please type your name, and it's going to wait for input. And you're going to say, Pearl, you idiot, I just typed you my name. It's going to say your name is not equal to your name, and then it's going to do it again. So what does it want?
Your name.
Your name.
It wants
It was-
the literal your name, right? That's what this
Then
thing
it'll
wants.
print out thank you then.
And then it'll print out thank you when you're done. That's
But
exactly
you don't
right.
know what's going on the top. So, right?
Yeah, that's why it's a jerk program. Because you can only understand what this program does if you understand puns or if you have the source code.
But I mean, the user doesn't have to worry. All the user gets is a request. And the name equals 0 is setting up one of those Boolean factors again, which is how they all work.
Input goes out to the user. So input's going to go to the user and get
Yeah, yeah.
Right.
But he doesn't know that name was set to nothing and then while name is not.
Right. It's just going to keep asking him until he types in your name.
Yeah.
Is this a fundamental
So what's wrong
Python
with
joke?
the program? Again, I don't understand.
There's nothing wrong with the program. When someone asks you, what is your name? If I say, what is your name? What are you going to respond with?
You said that this was a stupid program?
Right.
Well, why isn't it a good program?
Because if I ask you and I say, what is your name? What is your response?
Ralph, but what does that have to do with programming?
Stay with me for a second.
All right.
If you tell me your name is Ralph, and I say, no, what is your name? And you say, Ralph, and I say, no, what is your name? And then you finally say, what do you mean? And I say, this is what I want. I want you to write this, your name.
Yeah, right.
That means a literal thing to a computer. That's the worst thing writing. I apologize. the names of my elementary teacher. If I tell you to type in this, and I ask you that as a question, you're going to keep telling me your name. It means something different to you. Your name is Ralph. But the computer wants you to type in this string. That's what you're missing, Peter. You're missing that when it says at the top, I feel like if I walk, I'm going to die.
You can take that mic off.
While name is not equal to your name, that is a literal string. It's comparing the input you give it to the literal string, your name. It wants you to type in the string, your name, not your name.
As long as you're typing in anything other than your name, it's going to keep going in.
That's right. Let's run it. Let me show you. Peter, we're going to run this code. We're going to go run. We're going to go scratch. Please type in your name, Evan. Please type in your name, Evan. Please type in your name, Ralph. Please type in your name, Ralph. Now here's the catch. Please type in your name, your name.
Oh, for Lord's sake.
That's actually probably because if one person asks, 10 people are thinking it, right? So there we go. Yes, that's why it's a jerk program.
Can
Okay.
I point out one silly thing? Name was not initialized to 0. It was not initialized to empty. It was initialized to a string variable. So like, if you, so somebody typed like name equals 5 instead of name equals apostrophes, it would break, right? No? No, never mind.
Yeah.
Forget I said anything.
Okay.
Can we edit that out?
Would it help to remove the breakpoint and actually step through the debugger?
It would, but we're not doing that now because we have literally 20 minutes and I want to continue to cover this. Yes. But everyone understands what is going on. And we're going to cover debuggers in a later chapter. Okay. So here's the thing. How else can we structure this, right? Well, here's another thing. If we say while true, that loop is going to run forever, right? Let's come down here. If I say while true, let's get rid of that whole silliness, right? Now this piece of code is never going to stop, right? If I go run, and then I say run, and I say scratch, there's nothing I can type here that's going to get this to stop bothering me. Even if I say your name, it's not going to stop, because this is always true. So how do you get it to stop, right? Python has a thing called break, and you can provide it inside the loop, and it says, okay, time to quit, let's get out of here. So if I put this down here, right, like this, and then we run this code, run.
It asks you one time and then it breaks.
Please type your name, Evan, and we're done. Because we broke out of that. Now this break can be in a conditional. You can say if something break. You can say whatever you want. But break means we're done looping. Exit the nearest loop. We're out of it. Right? And that's really all there is to break. Now we come down here and we see continue. Okay, so now we know about break. What does continue do? Well, if we look here, if I said something like this, please print your name. Name equals input, right? And then I can say break. Let's say here, counter equals counter plus 1. Counter equals 0. If, we'll say here, name equals Evan. Okay, what is this code over here? If name. There we go. Okay. What is this code going to do? Actually, I think with this, you could actually say, let's see if they're showing it. Yeah, okay. While true. Okay, this code, right, is going to say, If the name is not equal to Evan, if your name is not equal to Evan, then continue. If your name is equal to Evan, increase the counter by 1, right? And then what we can do is, every time you give me a different name that's not Evan, it's going to loop back up to the top and it's never going to count it. If you give me Evan, it's going to get to the second condition and then loop back up to the top. So how would I make this thing end? Right, I could say this, if name equals Evan, continue, and then I can say, there we go. Now it's going to ask you your name twice. Right? If you give it Evan, it's going to say okay, and it's going to increment the counter. And it's going to ask you again. If you give it Evan again, it's going to break. If not, the counter just gets incremented. So when we run this code, please type your name, Evan, the counter goes up. Bob, it restarts. If I say Bob, it doesn't increment the counter. If I say Evan, it increments the counter. If I type in Evan one more time, we're out. Right? So you could do something like this. The point of continue is whenever you see continue, you stop where you're at and you go back up to the top. Right? If you don't hit the continue, you keep going on. And what happens when you go on? It asks you again for your name, and if you give it the name again, it breaks. So if we look at their code, let's take their code and we're going to copy and run it. Totally different example here. What's up in the back?
You use continue equals continue plus 1. If you had said continue equals 0 in the beginning, Python assume continue starts at 0?
The counter. The counter. Not, it was counter, not continue. I did use the word continue, but there was another word in there called counter.
Sorry, I made counter. I got that too.
Yeah. So Python, I started my counter at 0. I put that at the very top of the loop.
What I'm saying is if you did not do that, would it Python assume that counter started at the value of 0?
I think it would actually error. I'm not 100% sure though. It would error. Yes, it would error. It would error. Because you can't, if you say something like this, right? If you say, if you don't define it and you say A plus 1, no, I already got A. Let me give you something else. Evan plus 1, right, like this, it's going to come back and say error. Evan is not defined. You have to define your variable before you can use it. So you have to set it to something. So you set it to 0, and now you can say Evan plus 1. If you don't define it first, you can't ever increment it. So it wouldn't simply not run. Okay, so we have this one here. This is another one. What are we doing here? Who wants help reason about this? Next to Perl. You want to give it a shot?
What's the question?
Help me reason about this code. Tell me what it's doing. Before we run it. So the while true does what?
Sorry, you caught me while I was.
No problem. You want to give it a shot? What does while true do?
It just enters the loop.
It enters a loop, and how long does it loop for?
Infinite.
An infinite. It enters an infinite loop. That's beautiful. What's your name? Veronique. Veronique. Veronica, you want to help me out? Tell me. Okay, so now we're in a loop. It's an infinite loop. What's happening?
So it prints out how are you?
Prints out how, who are you? And then
Who are you, sorry. And then it asks for, I guess, the name.
That's exactly right.
And if the name is not equal to Joe, then it continues and it asks you again, who are you? Right?
Right. And if the name is equal to Joe, then what happens?
If the name is equal to Joe, then it's gonna print hello Joe, or it's the password.
Exactly.
Something else. And then you input the password. And then if the password equals to swordfish, it breaks and it goes out the loop.
That's exactly right. Breaks out and says access granted. Exactly, 100%. Nailed it. Very good. Awesome. So that's it. So who are you? You give it a name. If the name is Joe and asks you for your password, if you get the password right, it breaks out and you're granted. There's a case where you have a continue and a break inside of a while loop. You don't typically see this kind of stuff, right? Normally you see one or the other. You don't normally see while loops with continues and breaks, and you're going to see reasons for that later. But nonetheless, they show them off. Okay, so yes.
For that example, if the password wasn't swordfish, where would it jump back to?
If the password wasn't swordfish, then what would happen is you would. That's
You would
a
have trouble
really-
loop, right?
It would end the loop, and it would still print out access as granted because the code is actually wrong.
No.
That's the end of the while loop, the block.
Yeah,
So it's
go
just-
back, you tell me it would start all over.
Oh, that's the end. What?
The block, the while loop block,
Yeah.
that's the end of it, and you're doing while true. So it's just gonna iterate again.
You don't get to break if you don't have, if your if with the password is not true, you don't get to break. You go back up.
If with the password is not okay. Yes, there you go. That's what's happening.
That's the condition.
Yeah,
If
yeah.
it's false.
If the password isn't true, right? If you don't get the password right, then what actually happens is you don't break out of the loop. So the whole thing starts over. And rather than it just simply asking you for your password, it asks you again for what your name is. That's what's happening. So this is actually supposedly should go down. And this is kind of awkward in my opinion, but yes, that's what's happening. It would make more sense to write down access granted and not just break out of this loop ever, right?
Yeah, so it's confusing, but if you were to
Yeah.
add line 10 while password and did it once,
Right.
then maybe that would kind of show the.
Well, I was just thinking, this is effectively the same thing as this, right? You could come up here, you could move this access granted up. Let's just show this off. You could say this, and then you could say break, and it's the same thing right there, right? If password equals swordfish, print access granted break. That just seems simpler. But yes.
Simpler, but it's not illustrated.
Yeah, the point is, I agree. The point is that if you put the break here, then what actually is going to happen is, if the password equals swordfish, you break out of the loop. If the password is not equal to swordfish, then you simply continue. You do what would otherwise not be there. If this wasn't there at all, you would just restart this loop and keep looping. And because this is there, you have an out, but only if that's true. Okay. So, I don't know that we're gonna. Ed, give me advice here. Do you want me to cut this off, or do you want to start off next week on this chapter?
Not here.
Aha. Okay, well, we're gonna keep rocking that. I think what I'm gonna do is I'm gonna leave off on this, and then we'll just start next week with, because we did breaks, we did continues, but there's still more to go. There's an equivalent while loop. They're gonna show how to construct that, and we're gonna start off next week on that. So there are like 5 problems, but they're very close. If you want to try these practice questions, I think that's a good idea, and then we will review them next week in class. And we'll pick up the class. They'll cover rewriting the while loop, and then we'll go into those practice examples. All right.
Thank you.
We'll go. And if you're not in the Discord, grab the Discord. If you have any questions, ask in there, because we're there to answer. Oh, you want the...
Can I get that from you? Your calendar?
Yes, let me see here. Do you have a memory stick?
I do.
You're not teaching the next one?
I'm not, no. That's going to pick up on the next one.
Okay, do you alternate or is it?
We alternate.
Okay.
I'll do one, and then Ed'll do one, and then I'll do one.
Thanks for letting me camp out.
No problem. Hey, we had plenty of space anyway. So well, we had space. It was we were a lot closer than I thought we were going to be. But yeah,
All right.
it'll definitely not be as busy next week as it was this time.
All right, well, I'll see you then.
Very cool, my friend. Yeah.
Good
Here you
luck.
go.
What meter?
Thanks for doing this, man. Worked perfect. Marco here. Okay, you're Mark or Marco? I'm Mark. You're Mark and you're Mark ED on the track. So we spend a little bit more time. What is that? Well, is it a USB mic? Is it a USB?
It's not a USB mic.
There's no analog.
But it seems to work. So we didn't actually listen to it.
Yeah, I tried listening to what I got before the class started. It's okay. It's not great. It's probably going to pick up. It's got a lot more noise in here after I started.
We're doing so now. So we're going to be all going out to a place called Flying Pho. Yeah, you're more than welcome to come out and join us. Yeah.
Is that okay?
Yeah, definitely. We encourage it. Reminder, we're all going to Flying Pho afterward. Come on out.
Yeah.
And who's there?
Yeah, do we have a few minutes?
Is it a marker? I have no idea what a marker is. Is it a video camera or is it DSLR?
I have to. But I do my name. Where is it from? What time?
Yeah. The internal. The desktop. I don't want to just yet. Because I don't know that I'm going to edit it. You know, like my understanding is you're going to edit it when we have to. Well, you might want to put stuff I have. You might want to.
No, it's another.
Last screen assets, yeah.
Well, we're not making sense you can here, man. Like, I mean, I think we can kind of.
But you were worried about having coverage with the battery.
Yeah, that ended up not happening. She ordered that and she picked it up. So the team went out. And I think I got most of it.
Recording it.
Yeah, and so I watched a few seconds here and there, but I think I caught it every time. I'll see what I have.
Yeah, I hear what you're saying. I have a habit of being, I don't get involved at all. Getting out my front.
Yeah, Robbie's not well. I gotta go home and care for him.
I couldn't communicate that any easier without running it. I felt like when you were asking about your name thing.
Well, I kept looking at it and
it didn't compute. Yeah.
Well, the input is just one of those things that I can't twist it enough.
Yeah. We got you there, though.
But again, the guy didn't want the program to make sense. He just wanted an example
of a jerk program. Yeah. What doesn't matter to me, I think we find
It's not.
I'm just saying with zero
You can probably put a Periscope too.
Let's spend this time playing testing email software.
But I mean, we could probably do it multiple ways. It doesn't matter.
It's software for OBS. Try a camera switcher. Yeah. And you can also take video from your iPhone by USB or wireless.
Really? So,
but I mean, we have.
Which I think means I need to get that.
Are you just going to have separate cameras?
I mean, like the live stream and the take home stream. It's definitely going to be doing it. I mean, I can add more shit. I don't think it's necessary.
there's a Wirecast. There's a software that's not free, but one of the cool features is it takes all iPhones to make it like a source. So anybody with an iPhone can take it better. It's like a source. Zach, you got a memory stick? This would be kind of cool. One of the limitations you may find is the mic is over here.
No, it's not ideal. But if I was up there, you'd see full floats. So, as far as the picture goes, I'm going to see how bad it goes.
His lens was too long of a lens.
I have a fact. I should switch this up. This is Canon,
I was. Is this still your first program?
They do. It's really cute.
It's silly, but it's. Sometimes they can only do
Where does it come from? I was trying to give you just,
But the other one, I'm trying to remember.
That's the weird part when you're first learning it, because you're like, yeah, that makes sense. Yeah. Yeah, or to like be able to like make it create anything. It's like there's this like
It could also mean that like there's so much
learning curve where it's like you start gathering information and you can't do anything with it. Like kind of feels like a really long time.
I have some
And also right now.
I had like 30 minutes set up and I never streamed it before. Do you want to try setting it up before we go?
Yeah.
Okay.
Yeah. Or like
experiment with whatever you want. Yeah.
I'm using, one of the things I'm doing.
I